Hello students. Today we are going to discuss about the unit 11, that is area of polygons. In this unit we will be going to discuss how to find the area of quadrilateral, how to find the area of rhombus, how to find the area of trapezium, and at last how to find the area of some regular and irregular polygons by dividing them into triangles and quadrilaterals. So do watch this video. Now students, see, if you want to find the area of this quadrilateral A, B, C, D, how we will find? This AC is the diagonal of this quadrilateral, one of the diagonal, and this diagonal divides this quadrilateral into two parts, see, 1 and 2. Okay, if we will find the area of this one part and the second part, and we will add the two areas, then we will get the area of this whole part. So this is the simple concept behind the area of the quadrilateral, is how we will find. Now let us understand. So if you want to find the area of A, B, C, D, then what we will do? We will find the area of this first part. And what is the first part here? See, it is the triangle ADC. Okay, area of triangle ADC plus then second part again area of the second triangle ABC. So you write down area of triangle ABC. And we know what is the area of the triangle? Half into base into altitude. So here we need to find the altitude. So let us see. From a point D, what we will do? We will construct one altitude. This is suppose P. And this from B, we will draw one another altitude for this triangle, and this is Q. So this is the altitude for this triangle 1, and this is the altitude for this triangle 2. So what is the area of the triangle ADC? Half into base. What is the base? AC. Okay, and altitude. What is the altitude? Altitude is DP. Correct? Okay. Now let's see. It is the triangle, another one, second part, and the area of this triangle is half base. What is the base? Base is C again, AC. And what is the altitude? Altitude is BQ. Now see, half multiplied by AC multiplied by DP. Half multiplied by AC. That means we can take half multiplied by AC as common. Yes? Then what we will get? We will get DP plus BQ. Now let us see. What is this? Half multiplied by, this is diagonal of the quadrilateral. So whenever we will get the diagonal of the quadrilateral multiplied with this DP into BQ. DP into BQ means what? Sum of perpendiculars on the diagonal of the quadrilateral. So it will be sum of perpendiculars. Sum of perpendiculars. But sum of perpendiculars where? On the diagonal of the quadrilateral. So in the diagonal of the quadrilateral. So students, if somebody asks you what is the area of the simple quadrilateral, then we can say that area of the simple quadrilateral is half multiplied by diagonal of the quadrilateral. That means what is the diagonal of this quadrilateral and sum of the perpendiculars. If we will draw the perpendiculars on that quadrilateral, then the sum of these perpendiculars of the quadrilateral. So this is the formula to find the area of a quadrilateral. After this, students, we will going to find the area of rhombus. So let us write down the area of rhombus. Area of rhombus. So let us draw one rhombus. this is rhombus. Suppose this is a rhombus. Rhombus A, B, C, D. Correct? Now let us see. This is the diagonal of a rhombus and this is another diagonal of a rhombus. So they are intersecting at point O. So we need to find the area of this rhombus. So how we will find it? See, area of ABCD. That means it is the rhombus here. So as we have already discussed that the diagonal of a rhombus bisects each other at 90 degree. That means these angles are 90 degree. Okay, and another property is that diagonals of a rhombus, whenever they bisect each other, they will form the four congruent triangles. That means the rhombus will be divided into four congruent triangles. So if we will find the area of one part, that means the area of another three parts will be same, because these are the congruent triangles. Okay, so what we will do, we will find the area of this one part, then we will multiply it by 4. So what is the formula then? 4 times area of any triangle that you will take. Which one? So we will going to take the triangle number 1. So let us take the triangle number 1. Why we are taking only one triangle? Because the diagonals of a rhombus bisect each other at 90 degree. This angle is 90 degree and all the four triangles that are forming are congruent to each other. So area of triangle AOB. So let's see, 4 multiplied by, what is the area of triangle AOB? Yes, it is half into base. Base means what? A perpendicular. So it is the perpendicular, it is the 90 degrees. So what is the base? The base will be our AO. This is the base, and half into base into altitude. What is the altitude? Altitude means it is the perpendicular. Okay, so this altitude means OB. So now if we will convert this half multiplied half of AO, see, and multiplied by OB. What is AO? AO means this part, and we know that diagonals of a rhombus bisects each other. Bisects means this part is equal to this part and this part is equal to this part. Bisect. So AO we can write down as half of AC. This AO we can write down half of AC, and this half is half here. Okay, then OB. Again OB is half of BD. Now let's see. This 2, this 2. 2 to the 4, 4 cancel. We will get half multiplied by AC into BD. So what is this AC? Half means half, AC means AC, and BD means BD. So area of the rhombus will be half multiplied by product of diagonals. So product of diagonals. So this is the important formula related to area of rhombus. Whenever the rhombus will be there, it will divide, the diagonal will divide the rhombus into 4 congruent parts, and each parts are equal. So that means if we will get the area of one part, another 3 parts we definitely get, and this is the whole part is that half into product of diagonal. Now we are going to find the area of trapezium. Suppose this is the trapezium A, B, C, D. We are going to find the area of trapezium. Okay. So before finding, let us draw one perpendicular from point D to this is point line AB. That means it is a P, and we can write down a H unit. Okay. Then from this point C, again we will draw one perpendicular to this point. Line segment AB. It is PQ. Suppose it is H unit. Now we are going to find the area of this trapezium. If you will observe here, students, what you will get? You will get that this trapezium ABCD can be divided into 3 parts. The 1 part, this is 2 part, and this is 3 part. Yes. The first part is our triangle. Triangle APD. The second part is our rectangle C, DPQC. And the third part is our again triangle BQC. So what we will get? If we are going to find the area of ABCD, then we can find that this area can be split into 3 parts. This is area of first part plus area of second part plus area of third part. Yes, if we will find the area of this, this and this, and we will add this area, we can get the area of this trapezium. Now what is the area of first part? It is the triangle, see, DAP. And what is the area of triangle? Half into base. Base means it is AP, and altitude. What is altitude? DP, because it is a perpendicular that we have drawn of DP. DP means H unit. H plus area of this second part. It is the second part is a rectangle, and this area of rectangle is length, means it is PQ, and breadth. Breadth means this is H. Okay. Then what is the third part? Third part is our triangle CQB. That means again half. Base means QB, and altitude means height. This is the height of the triangle. Now let us see. From this we can take half H. Here half H. But here it is PQ. Again we will take the half H from here. Half H common. Then what we will get? AP plus PQ. See, it was half PQ we have taken common. Then it is always simple PQ. So we can write down it is twice PQ. See what will happen. Twice PQ multiplied by half. We have taken the half common. We will multiply it. We should get PQ only. See, we are getting the PQ. It is a type of factorization, taking the monomial and polynomial. Okay. Now see, it is plus BQ. Half H we took common. So what we will do? Half multiplied by H. AP plus PQ means it is PQ plus BQ plus it is PQ. See, PQ plus PQ, it is 2PQ. So we have separated this PQ there. Now see, half into H. AP plus PQ plus BQ. AP plus PQ plus BQ. That means it is total AP. And plus it is PQ. What is PQ? PQ is equal to this part, DC. So it is DC. Now see students, what will happen? If we are going to find the area of the trapezium, then the area of the trapezium will be like this. See, half multiplied by perpendicular means height of the trapezium multiplied by what is AB plus DC. AB plus DC, sum of, these are the parallel side of the trapezium. So we can write down sum of parallel sides of the trapezium. This is the formula related to area of trapezium. Based on this formula, we will going to solve the problems of our exercise 11.1.